Great. So this is mathematics paper 1, content for mathematics paper 1, KCSE, of course, form 4, which is very relevant also to form 3 students. Remember, paper 1, basically they test stuff from form 1 and form 2. Form 1 and form 2, right? All that content will find its way in mathematics paper 1. So, and I would want us to start right away by looking at the least common multiple of these two numbers, 12 and what here? 15. For me to be able to get this least common multiple of 12 and 15, I would need to appreciate what we call prime numbers. Prime numbers. So you're saying very importantly there, if you're writing, that it will be very important for us to know how to make use of prime numbers in ascertainment of the LCM. LCM, then how do I do this? I'll come and do a small table here, 12, 15, 12, 15. So in this case here, ladies and gentlemen, I shall start right out with the smallest prime number. Remember remember how these prime numbers here look like. So we'll start with 2. 2 is the smallest prime number. After 2, somebody who is following after 2, which is the next prime number. The next prime number. The next prime number after 2, the next prime number is what? Somebody go to the chart section and then you type there. Chart section and then you type there. I hope you are able to see the chart section. If you're not able to see the chart section, your parents can assist you. Your parents can assist you. So after 2, 2 is the smallest prime number. Smallest prime number. So after 2, we go next is 3. You guys are correct. Thank you so much. So after 2, of course, the next prime number will be 3. After 3, the next prime number will be which one here? Somebody after 3. After 3, the next prime number will be which one here? I hope nobody will think it's a series. And then they tell us 4. Then they tell us 4. No, after 3, the next prime number will be 5. Will be 5. So we have 2, 3. Then we have 5 there. Of course, 7 is a prime number. 9 is not a prime number. 9 is not a prime number. Why is 9 not a prime number? Remember, 9 can be factorized. 9, ladies and gentlemen, 9 has got a divisor. You see, 9, you can divide 9 by 3. You see, all these numbers here we are calling prime numbers. For you to drive them to 1, basically, for you to be able to drive them to 1, you can divide them, of course, by themselves. Right? For you to get a whole number. For example, if I want to get a whole number, I can only come and divide this by 2. So if I divide 2 by 2, I'll get, in this case here, a whole number. If I divide, that's 1. 3 divided by 3, I'll get 1. 5 divided by 5, I'll get 1. 7 divided by 7, I'll get 1. There is no any other number in between here. If I try, for example, dividing 3 by 2, I'll end up getting a decimal. If I try dividing 5 by any other number, even if I try, for example, dividing 5 by 4, I'll end up getting a decimal number, 1 point something. But you see, a number like 9, there is a number in between here that I can divide this 9 with. I can divide 9 with 3. So it means I can divide 9 by 3 and still I'll get a whole number. So it means that 9 is not a primary number. 9 is not a primary number. I'll be getting into this deeper. But a number like 11, ladies and gentlemen, is a prime number. It's a primary number. Right? So then we shall start in this case, ladies and gentlemen, by appreciating these prime numbers for us to be able to get the least common multiple. So like now here we have 12 and 15. So I'll ask myself whether the very smallest prime number that we have is able to go into any of these years. 2 is the smallest prime number. So 2 will be able to go into 12. So then what I'll do, I'll talk of 12 divided by 2. 12 divided by 2, ladies and gentlemen, gives me what there? 6. When I go to this number and I pick 15 divided by 2, I'll end up getting a decimal, which is 7.5, which will be wrong. I would want always to work with whole numbers. So when I realize that when I take like now this 15 divided by 2, I'm going to get a decimal number, I'll simply carry this figure the way it is as a whole number. So that is what here, somebody 15. Right? Listen, now I'm in my second step. In my second step, before I pick the next prime number, I'll need to ask myself whether we have any of these two numbers that are inside here still being divisible by 2. I have to exhaust 2. And yes, I know that 6 can be fully divided by 2. So I'll come and put 2 there. And then, of course, go ahead and divide this. So 6 divided by 2 gives me 3. 15 divided by 2, I'll end up getting a decimal 7.5. So it means that I can't divide this with the 2. So I'll have to bring this forward, the whole of it. I bring this forward, the whole of it, to 15 like that. Now, from there, now the third step, of course, I know now there is no number here that can be fully divided by 2. So I go to the next prime number. And the next prime number you guys have told me is what here? Is 3. The next prime number you've told me is 3. So 3, how many times here? Of course, 1, right? 3, how many times does 3 go here? Fully 5 times. So I'll be able to divide here by 3. I get 5 like that. Right. Now, ladies and gentlemen, please listen. After that, I'll come and ask myself, still the way things are here, can we have a still 3 going to any of these? No. So then I jump over to the next prime number. So the next prime number you guys told me is what here? Is 5. So when I take 5 here, of course, 1 divided by 5, I'm going to get decimals. I can't entertain that here. So it means 1 divided by this because of I'll just pull this down. So I'll come and put there 1. And then 5 divided by 5 gives me what here? Somebody gives me 1. And then automatically now this is the end of the thing. Because when I'm getting the LCM, my work is to drive these numbers here all the way to 1. I drive them all the way to 1. And then, ladies and gentlemen, for me to be able to get the LCM here, what do I need to do? I need now to come and look at this term and multiply all these numbers now. I'll multiply all those numbers. So in this case here, the LCM will be 2 times 2 times 3 times 5. So could you kindly give me this figure? Could you kindly give me this figure? So Billy Kintu gives me a figure of 60. Gives me a figure of 60. Teresa also is confirming that 60 is the correct answer. Thank you so much. 60 is the correct answer. 60 is the correct answer. But now remember, your mathematics paper 1 examiner cannot test you directly like this. What this gentleman or lady will do, your examiner, what they will do, this is what they will do here. Like in 2022, they gave us a very good question. In 2022, this is what they did in 2022. This is what they did in 2022. If you're ready, ladies and gentlemen, I'll be able to dictate this question to you. I don't know whether you guys have access to these KCSE papers. I'll assume that today you don't have access to them, and then I'll be able to write this down. So we have here KCSE 2022, question number 2, which wanted us to make use of what here? To make use of this concept of LCM. So we're writing the question down that two bells ring at intervals of 35 and 42 minutes respectively. Right? Respectively like that. Full stop. The bells rang together at 8:48 a.m. in the morning. That's when they rang together. So they want us to determine the time when the bells will ring together again. So they want us to determine the time when the bells will ring together again. So I would want to know whether, first of all, you guys have been able to copy this question in your books. Once you finish, you simply write there, Y for yes, or you send an emoji. That is what we call an emoji. Emoji comes from the word emoticon, or emotion. So you can, in this case here, go ahead instead of typing so many things, and then you type, or rather you send an emoji like that, which is smiling. Or when you have questions, you send an emoji that is crying. I'll be able to pick yes. I'll be able to pick. Yes, I can see already Irene has been able to know how to use it. Thanks, Alice. Great. And that is how we shall be studying here. We must know how to make use of what here? Emojis here. That's how we bring our class live. Great. Great. Now, ladies and gentlemen, there is some commonality here. We have got two bells. We have got two bells. The first bell, we are told the interval is 35. Every 35 minutes, it has to ring. This one is every 42 minutes, it has got to ring. And then they have given us the time when they rang together. And then they would want us to tell them, of course, in this case, the soonest, what is the soonest time that these bells are expected again to go up together, right? So I can see the concept of determine the time when the bells, both of them, will ring. So I can see the concept of soonest. I can see the concept of common. So I can see the concept of LCM being applied here. So here, the very first thing they wanted us to ascertain, ladies and gentlemen, the very first thing they wanted us to ascertain, ladies and gentlemen, is the LCM between these intervals. So give me the LCM between 35 and 42 using the method that I've just shown you. Remember, mathematics paper 1, speed is of essence. Like now I can see Bill Kintu already has an answer. I can see even Teresa, even Kambak already has an answer. 210, 210, 210, 210. So speed is of essence really here. Speed is of essence. Speed is of essence. Speed is of essence. So then what I'll do, ladies and gentlemen, here, because I can see already you are getting this thing very nicely, what I'll do, I'll come and provide a solution straight away. I'll provide a solution straight away. I should be able to provide a solution here straight away. So what do they want me to do? They want me to give them this LCM. So then this LCM, I'll come and do my table. 35, we have got what here? 35, this V42. So I'll draw my table like this. So remember the concept of prime numbers. Prime numbers, I can even write them up here so that I don't get confused. So we have here 2, 3 is the next prime number, 5. We have, of course, they can't go really very far. Let me just put it just for the sake of that, 7. They can't go very like to 11. No, it's not that easy really. So we start always with the very lowest prime number when you want to get LCM. So the lowest prime number here is 2, right? So is 2 able to go into 35 fully? No. So then I'll be able to pull down the 35 here. Is 2 able to go to 42 fully? Oh, yes. So 42 divided by 2 gives me 21. All right. So I'll ask myself before I jump ship from 2, I'll ask myself whether there is any number between the two that can be wholly divided by 2. Of course, there is none. So automatically then I'll go to the next prime number, which is 3. So can 3 go into 35 fully? No. So 35 divided by 3, not possible. If you try taking 35 divided by 3, of course, you will get some quotient there. You're going to get, in this case here, some value there, but the value will be decimals. And then we don't entertain decimals. So in this case here, we want 35 divided by 3, not possible. Pull it down. 21 divided by 3, oh yes, 7. 7 like that. Ladies and gentlemen, from there, of course, now I know there is no possibility of 3 going into any, right? So I'll go straight away to 5. So can 5 in this case here go to 35? Or can it go in 35 fully? Oh, yes. 35 divided by 5 is 7. Can 5 go into this fully? No. So I carry down 7. From there, of course, ladies and gentlemen, I can see, of course, I can't repeat this 5 because 5 can't go now to any. So the next one will be 7 there. So which in this case here drives everything to 1 and 1 like that. Ladies and gentlemen, then this LCM here will be equal to, I'll now come and use this the primary numbers. So I have 2 times 3 times 5 times 7. I to believe that this is what will give us 200 what here? 210. 210. So these are 210 minutes. I would want to convert these to hours. I want to convert these to hours, and of course, the extra will be minutes. So can somebody talk to me this afternoon? How do I convert these to hours? 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 Somebody talk to me. Divide by 60. Thank you very much. So divide, we know that 1 hour has got 60 minutes. So divide this by 60. So if I do that, then this one here will give me 21 over 60. 21 over 6, I mean, because I'm canceling that 0, 0. So, ladies and gentlemen, 6 can go into these wholly. 6 can go into these wholly. How many times? Of course, that will be 3 times. So 3 times, 3 times. So basically, these are 3 whole hours. So 3 times. Of course, you know, if you try, I know you guys are good in this. If you do here 6, 21. So you're saying 3 will give me 18. All right. So in this case here, once I have 18 here, then I'll be having some remainder. A remainder of what here? 3. So then as an improper, you know, this is an improper fraction. So when I want to make this proper, I'll talk of 3 hours into this remainder, which is 3 out of what here somebody, 3 out of what here somebody, 3 out of 6. I mean, if you try converting this to an improper fraction, ladies and gentlemen, it will be 3 times 6 plus 3. 3 times 6 is 18 plus 3. If I try converting this to an improper fraction, so it will be 3 times 6, 18. 18 plus 3 is 21. So 21 over what here? 6. I would want you to see this. There is a very important approach that I would want you guys to see here. A very important approach that I would want you guys to see here. You know, this one here will be 3 hours, or rather 3.5 hours, 3.5 hours. But you see, I would want to know how many hours, how many minutes, how many hours, how many minutes. There are many ways you could use to get, in this case here, how many hours, how many minutes, how many hours, how many minutes. I like this. I like this. I like this. If I'm the one doing this question, ladies and gentlemen, I will appreciate that this is the same as a half. 3 over 6 is the same as a half. Or I can even leave it like this so that I handle this thing this way. I'll say 3 hours and how many minutes here? 3 hours and how many minutes? 3 hours and 3 over 6 times 60 minutes. Minutes like that. So this one will give me 3 hours and how many minutes somebody who is following? How many minutes somebody who is following here? 3 hours and how many minutes here somebody? And 30 minutes. 3 hours and 30 minutes. 3 hours and 30 or 3.5 hours. I don't want to write it this way. I don't want to write this way. So it means, ladies and gentlemen, that these 2 bells again will come to meet exactly after 3 hours and 30 minutes. But you see, this examiner is a great examiner. He wanted you to determine the time, the exact time. You know, this is an interval. This is an in-between. The exact time when we expect these 2 bells to ring together again. To ring together again. When we expect these 2 bells to ring together, remember they had rung together at 8:48. So the time they'll ring together again, the time they will ring together again, the time they will ring together again, the time they will ring together again. Remember, we have now 8:48, right, AM. And we know that these 2 bells will be ringing again exactly after 3 hours and 30 minutes. Remember, these are minutes. 3 hours and 30 minutes. So please go ahead and do what here, somebody? Yes, go ahead and add for us. When you add here, this is 8. This is 7. There is no way you can talk about minutes really. When these minutes in this case here exceed 60, right, you must carry forward the 60 to hours side. So in this case, ladies and gentlemen, because I can see 78 here, I must deduct 1 hour, right? So in this case, here, instead of saying 78 here, instead of saying 78, I must deduct 1 hour. I take the 1 out of the side. So it means that when I deduct these 60 minutes, then here we're going to be left with 18, right? So in this case here, the 1 hour is being brought to the hour section. So meaning if you count here, of course, I can see 8 plus 3 is 11 plus this one, which was carried forward. We are talking about what time they are. So we expect these bells here to ring again at 12 when? 12:18. But you're going to lose a mark if you don't tell us whether it's AM or PM. You're going to lose a mark. You're going to lose a mark. So should it be AM or PM? Remember, we began at 8:48 AM in the morning. Right? So this has to be 12:18 what here? This has to be 12:18 PM. It has to be 12:18 PM. It has to be 12:18 PM. Now, the thing that I would want to sell to you here today, the first thing is how to get what here? This LCM, the LCM. Otherwise, this time factor, these are things I'll keep on repeating. It's good that your minister has extended your opening date. up to next week. Is it 18th? Around there, yes. So if you're going to be doing mathematics every day, you're going to learn so many things. So ladies and gentlemen, first of all, I would want us to appreciate the fact that have we learned how to get this LCM? Are we okay? Are we comfortable with the LCM calculation? Are we comfortable with the LCM calculation? Ah, great. Thank you so much. LCM calculation, great. Great. So please, if you have any question, ensure that you are asking questions in the chat box. In the chat box, they are very important for you to do that. Now, ladies and gentlemen, before I go to some great area in 2021, I would want us to remind ourselves. Here something small to do with what here? With matrices. Matrices. We take 10 minutes. Of course, we expect a question of matrices in paper 1. Matrices. Either they'll tell you to inverse, right? Or even ascertain a determinant, or even use these matrices here to solve simultaneous equations. So we know, and you should be able to write your notes that a matrix is a rectangular array, or arrangement of numbers enclosed in a pair of what here? In a pair of brackets. Enclosed in a pair of brackets. So a matrix is a rectangular array of numbers enclosed in a pair of brackets. So for instance, if you go to a good shop that sells clothes, right? You don't always get these guys here, for example, having, if it's shirts, these shirts here could be coming in form of what here? In form of sizes. So we have, for example, shirts type X and type Y, right? And they're coming in form of sizes here. So we have size 1, for example, and size 2, like that. So then shirt X of size 1 could be going for 300 shillings. Shirt X of size 2 could be going for 500 shillings. Shirt Y of type 1 could be going for 450. Type Y of shirt type Y size 2 could be going for something like, say, 900. So ladies and gentlemen, I'm conveying my information regarding prices, but in the form of what we call a matrix. You can see here, of course, a rectangle or a square arrangement of numbers enclosed in a pair of brackets. So this is what we call a matrix. Ladies and gentlemen, what are we required to appreciate about matrix here by our examiner? What are we required to understand about matrices by our examiner? Simple things. Number 1, the examiner expects you guys to know what we call matrix algebra. Matrix algebra. So under matrix algebra, your examiner expects you to know what we call addition, how to add matrices. Number 2, the subtraction. Number 3, we have a matrix multiplication. And then number 4, we have lastly, we don't have division. Lastly, we have what we call matrix inversion. Matrix inversion. So you talk of algebra. Algebra basically is the criteria that were given, in this case here, by these scientists who developed these things, which we can use to combine numbers, to combine matrices, etc. Ladies and gentlemen, please listen here. For me, I would want us to go it practical. So if, for example, here you are given 2 matrices, you are given like 2, 3, minus 5, 7, and then somebody comes and tells you to add this one here. Somebody comes and tells you to add this matrix to this one here. For example, 3, or negative 2, negative 5, and in this case here, 9, like that. Right? So I want to show you the first operator, the first section of algebra, which is what your 2 matrices being added. So how do we add? Remember, addition is straightforward. Addition, ladies and gentlemen, normally addition, you take the first ones added. You see, this is the first of this matrix, first element of this matrix. This is the first element of the second matrix. So you add what we call corresponding numbers. corresponding numbers. So could you then kindly tell me what is 2 plus 3? I write the answer here. 2 plus 3. I know it's easy, but to see whether you guys are following, I would want to get these numbers from you. And I'm so happy because I can see you guys are right. Teresa, is it possible you type? Thanks for raising your hand. It means you're good with Zoom, but I would prefer you type. You type your answer. So 2 plus 3, 2 plus, they're telling me it's 5. Thank you so much. Then I can see this one corresponds to this one. So you'll say minus 5 plus minus 2. Plus 5 plus minus 2. You are not supposed to struggle with body mass. Remember, nowadays you are given calculators. You are given calculators to use. I normally see high school students struggling with body mass quite a lot. Here, you know, unless the examiner tells you, like in some cases, of course, he'll tell you not to use a calculator, but here, use your calculator. You pick there, minus 5, you set again plus. Minus 2. Remember, a minus before a number is always part of that number. Your calculator has got body mass well inbuilt there. So can somebody give me this? Minus 5 plus minus 2 gives me what figure, somebody? So I'm being told here by Alice, it is minus 7. This is minus 7. Then we have here 3 plus minus 5. Now we have to increase our speed. Now you guys are great. You guys are going to pass highly. So 3 plus minus 5 gives me what figure? We have Irene giving me negative 2. Thank you so much. Thank you so much. And then we have 7 plus 9. 7 plus 9. 7 plus 9. This one here gives us minus, can't be minus 2. 7 plus 9. 7 plus 9 gives me what, ladies and gentlemen? Gives me 16. Gives me 16. So then what have we learned here? That if this examiner tells us to add 2 matrices, I will not sweat it out. If this examiner tells me to add 2 matrices, I will come and add what we call corresponding. Same position elements will always be combined. That's the first algebra. Now, I would want us to do example number 2. Example number 2, please let me rub this. We go to example number 2. We go to example number 2. So example number 2, example number 2, example number 2. So example number 2, we have here minus 4, 3, 8, negative 9. And then this person comes and tells us subtract. We have here minus 2, 3. We have here negative 2.5. We have here 5, like that. So again, he's telling us to subtract. So it tells us to subtract, I'll again not sweat at all. Mathematics doesn't love people sweat, right? If you want a clean A, don't sweat at all. So you're supposed just to have the concepts. So like now here, the major concept will be, again, for subtraction, we work with corresponding elements. So corresponding elements, what do we have? Like this is element number 1 of this matrix. This is element number 2 of this matrix, like that. So then what I'll do is to take my calculator. I'll not sweat out with body mass at all. Mathematics is sweet. So what I'll do, I'll take my calculator and then I say minus 4. Then we have this is minus. And then the number itself is minus 2. And then I say equals. I can see from Irene Mwangi that the answer here is supposed to be minus 6. Minus 6, I've used, Irene, have you used your body mass? You haven't used your calculator. Let me come with my calculator. I show you how we use calculators. And even if you got it wrong, don't worry. At least you have tried. Let me come up with a calculator. Okay, so here I have my calculator. I'll not try to write many things outside. If you write many things outside, you will not be correct. What you need to do, you see, so long as you've appreciated that we are subtracting corresponding numbers, and our minus before a number is always part and parcel of that number. So then what we need to do here is to come and say minus 4, this minus, and then there is this minus for the operation. So we have minus. I'll not put even brackets anywhere. Nowhere will I put brackets, right? And then I'll come and say minus what here? This is minus 2. The number itself is minus 2, minus 2. So in this case, what am I getting as a resultant figure there? Yes, I saw most of you had minus 2 there. Great. And then the next positional, the next element is this 3. So I'll say 3 minus 3, which gives me 0. Thanks, Bill, which gives me, I didn't thanks, 0. So go to the next one. This will be 8 minus 2.5. Using your calculator, you see somebody who has an answer already here. Using your calculator, we have Bill into 10.5, 10.5, 10.5, 10.5. Is there somebody who is able to confirm that 10.5? 10.5. Is there anybody who is able to confirm the 10.5? Irene, one just confirmed the 10.5. And I want to hear from everybody. Everybody here is great. Trust you me. Everybody in this room is great. All of us are going to pass. The only thing I need you guys to do is to be very courageous. Be very courageous. Yes. Be very courageous. So it is 8 minus 2.5. So it is 8 minus 2.5, which will give me 10.5. And then now we have minus 9 minus 5, which will give me minus what here, somebody? Minus 14, right? Minus 14. Great. Thank you so much. Now, if you allow me, I'll now take you to example number 3. Example number 3. Let's go to example number 3. Example number 3. So example number 3. Example number 3. So for example number 3, what do we have here for example number 3? Example number 3 will be given here 2, 3, 5, 4, 2, 1. And then somebody will come and tell you, hey, do what? Take this matrix, multiply it with the 4, 7, 6, 8, 9, 2, like that. So now we are multiplying. I don't know why I normally write my multiplication in a bad way, but at least that way will ensure that I differentiate between a multiplication and an addition in a way that everybody will be able to appreciate, right? Now, when I'm told to multiply 2 matrices, ladies and gentlemen, by any examiner, that's an examiner who is wishing me success. That's a good examiner. What am I supposed to remember when they tell me to multiply 2 matrices? I'm supposed to remember what we call Roman Catholic. Roman Catholic. Roman Catholic. That means that rows will always multiply columns. Roman for rows, Catholic for columns. Rows will always multiply columns. How do I do this? It is rows of the first matrix, times columns of the second matrix. Columns of the second matrix. Please write this, and if you have a highlighter, I would want you guys to highlight this operation of multiplying matrices. This is a very important operation for me. You take rows of the first matrix times columns of the second matrix. Rows of the first matrix times columns of the second matrix. I would want to know whether you guys have been able to write this and whether you've been able to highlight. Do you have highlighters? Do you have highlighters? If you don't have highlighters, I would request your parents to buy for you highlighters. Highlighters, yes. Billy Kinto says yes. So these are very important algebra called multiplication. 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 Ladies and gentlemen, please listen and listen to me very well. Listen and listen to me very well. Listen and listen to me very well. You know, a column is this one here that is normally vertical. Columns move like this. This is how a column looks like. And then, of course, we have a row is horizontal. A row looks like that. So we are saying that for the first matrix, we shall be taking rows, right? But the second matrix will be working with what we call columns. Now here, I normally see students writing so many things which they're not supposed to be writing. Here, you need a lot of courage. You're supposed to remember what we call run down the ditch. It's a row, column, row, column. And how do we do the row column? I'll take the first ones multiplied, plus the second ones multiplied, plus the third ones multiplied. I'm saying plus because at the end of the day, ultimately, I'll be required here to write one value. I'll be required here to write one value. So can we kindly do this together? So you're saying that, and you're doing this in your calculator. We are saying first ones multiplied. So it will be 2 times the first one here, which is 4. Plus second ones multiplied. So it's 3 times 7. So plus 3 times 7. plus the last multiple, third ones multiplied, which will be 5 times what here? 6. I would want to see whether there is anybody who has been able to get an answer directly without writing much. And to see what your answer is. And to see what your answer is. And remember, for Mwalimu here, in every class that I teach, I must give a present. Like here today, there must be somebody who will get a present. At the end of the class, I must give a present of 300 Kenya shillings. Of 300 Kenya shillings. So if you're very aggressive, you'll get 300 Kenya shilling, and I'll send to you your dad's or mom's number. You just give me your dad's or mom's number, we send that. So you must be very aggressive, really. You must be very aggressive, really. So they're telling me that this one, the first figure here, when we multiply Roman Catholic, the first figure that we will get here will be called what here? Somebody is telling me, Mwalimu, write 59. Write 59. I'm not yet done with you. This row has to multiply all the columns. So it has multiplied the first column. Now I would want it to multiply the second column using the same criteria. The first one's multiplied plus the second one's multiplied plus the third one's multiplied. So I'd want to see whether there is anybody who will be able to use that criteria to give me the second figure. And I supposedly think it will be correct. Let's see. So now we are multiplying this row with the second column. So we have Bilkintu giving me 53. Bilkintu is giving me 53. Right? We have a Skambak, Victor 53, Victor 53. Right? Moses 53. So remember, what you are expected, ladies and gentlemen, to do in Kcse, time is of essence, especially for mathematics, biology, even English. I mean, time is of essence. So the more the shortcuts you appreciate of doing these things, the better for you, right? So now we are here. We are saying it is Roman Catholic. It's running down the ditch. So I'll take the first ones multiplied. And here, for the many years that I've taught, I've always gotten students that I call left-handed, not left-handed, but how do I call it? I mean, you'll get a student in this case who does not want to move. So he'll tell you it is 2 times 8 plus 2 times 9 plus 2 times 2. You are a student who doesn't want to move. And yet matrices, as you run down the ditch, they would want you to be revolving the wheel. The wheel must revolve. You must move from one number to the next, right? Like take first ones multiplied plus second ones multiplied plus third ones multiplied. So, and remember, I'm using a calculator, not unless the examiner tells me not to use a calculator, and they can't tell you not to use a calculator in matrices. They can't tell you. Right? So we have here, let's do it together. For first one multiplied will be 2 times 8. Plus second one multiplied will be 3 times 9. Plus third one multiplied will be 5 times 2. Like that. Great. So 53 is correct. Let me ask you a question. Where should I write this 53? Because I'm still working on row number 1, it has to be here. It can't be down here. So that is where we put 53. From there now we shall go to the next lane. The next lane is this row. This row again has to, it's called an iterative process. It has to keep on repeating the same process that we did with the first one. So this row has to multiply the first column. This row has to multiply the first column. This row has to multiply the first column. And how do we do it? I'm not worried at all. I know the procedure. It is Roman Catholic, right? It is first one is multiplied, plus second one is multiplied, plus third one is multiplied. Thank you so much. I can see so many of you have really mastered the concept, ladies and gentlemen, here. So we are saying here, the first one's multiplied will be 4 and 4, plus second one's 2 and 7, plus third one's 1 and 6. So we have, ladies and gentlemen, here 4 times 4, 4 times 4, plus we have 2 times 7, 2 times 7, plus 1 times 6. Great, 36. They're getting 52. I don't know where, Alice, you got 52 from. I don't know, maybe you're talking of the next one. So let's agree, first of all, on this one, first one. Let's agree on the 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 first one. The first one. The first one, what figure were they getting here? The first one. The first one here. What figure were they getting here? Somebody, is it not 36 here? The first one. Okay, 36. And then now this one here is the easiest, because now I know I've already known the route to take. So I've already multiplied this with the first column. I'll go ahead and multiply this with the second column. How do I do it? This thing needs confidence. It needs confidence. So we have here 4 times what here? First one's multiplied. So 4 times 8 plus second one's multiplied, plus 2 times 9 plus third one's multiplied. So 1 times 2, which will end up giving me, you guys are correct. Would you kindly put a big tick there? Put a big tick there. Put a big tick there. Put a big tick there. And then, of course, I would expect you, great students, please, if you're not able to follow, tell me, hey, stop down. Put those emojis that are crying. Don't fear anybody. Don't fear anybody. I'm so sure there must be somebody who is seated there next to a parent. When I'm teaching, please, the parents or whoever, your guardians, they must give you time. They must stay away. And on that note, I'll take like a minute so that you can ask them. You need freedom. You need freedom. I know why I'm saying that. So if there is any parent who is even trying to hold their phone for you, no, you are mature. You'll be able to handle your issues. The parent should stay far away, so that there can be a communication between the two of us only. So that when you cry there, your parent doesn't get to see you are crying. So they can ask questions. Right? Now, can I give you one now you try? My first present goes to this student who will be able to get this question correctly. So this is the first question which carries a present. Look at this, the first question. And of course, the present will go to that student who will be the very fastest, the fastest to handle the question and get all the 4 figures correctly. We shall be able to give them a present. The question is here. -2, -5, -6, -7, right? And then we have here 6, 8, -9, and 4. Actually, just 2 figures. So remember, you're told you to multiply. So I'll just close my eyes and wait for your answers. Wait for your answers. It must be everybody participating, really. It must be everybody participating. It must be everybody participating. It must be everybody participating. Must be everybody participating, yes. Okay, according to Bill Kin 2, we have here -52 and 10. First one, second one, yes. So Bill Kin 2, ensure that you don't have anybody coming up and overtaking you here for the second row. Right. So according to Bill Kin 2, -52 and 10, -52 and 10, -52 and 10. So we have here -92 and 26. -92 and if you'll be correct, Bill Kin 2, already you have 150 Kenya shillings. 150 Kenya shillings. Yeah, in every class that I teach, I have to. So we have Moses who is saying -53 and 10. I don't know whether it's a typing error, Moses. Is it -52 or -53? Check again. But I love students who communicate. I love students who give me answers. Students who try. That will be very good, really. That will be very good. 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 Okay, great. Great, great, great. I'm waiting for the others here to talk to me. In terms of matrix multiplication, what do we have there? In terms of matrix multiplication, what do we have there? So allow me to do this. Allow me to do this very fast. So long as I appreciate the fact that matrix multiplication is Roman Catholic, row column, I will never go wrong. So and then I have my calculator. So I know first matrix, we are working this way. Second matrix is a column like that. So then how do we do this? We'll talk over -2, first ones multiplied, remember. So -2 times 6, plus second ones, -5 and 8. -5 times 8. I'm getting -52. This is correct. This is correct. And then now we go and take this and this. So we have here -2 times, -9 plus. Then we have -5 times 4. And then I say equals. I am getting -5. Nope, let's go slowly here. You know, it is this and this, this and this. Let's repeat this. So you're saying it's -2 times who? Times -9. All right. All right. Plus -5 minus times 4 equals. The first one, ladies and gentlemen, here is supposed to be -2. The second figure for the first row is supposed to be -2. Could you kindly confirm? Could you kindly confirm it's not -10? It's supposed to be -2. -2. Right. So, all right. So now we are through with the first row. Now come and do work. Same concept, same lane. Now with the row number 2. Row number 2. Is there somebody who can confirm, or in this case here, tell us that these figures are wrong? So for row number 2, I'm bright now. I know it is about this row with the first column. So I know it is -6 times 6 times 6 plus, we have -7 times what here, somebody? 8. -7 times 8, which will end up giving me -92. So this is very correct. And then this row is going to multiply the second column. It's going to multiply the second column. So we have -6 times -9 plus, we have -7 times 4, which in this case here gives me 26, which is correct. Correct. Now, ladies and gentlemen, if you allow me, I'll be able to go straight away to what we call inverse. The last operation is called an inverse. Please, I'll share this video with you. Immediately after our class, and I expect you to repeat watching it. You repeat watching it, because I don't want students to be writing this procedure. But -2 times 6 plus -5 times, this time of writing like this, someone else will have done it and gone to other things. So then now we are here on the last operator called who? Inversion. So then, gentlemen, for inversion, what do we have here? The first thing you're supposed to know is that the inversion is only applicable to square matrices. Only applicable to square matrices. You see, a square matrix is that matrix that has got the same number of rows with what here, somebody columns. Any matrix whose rows, number of rows equals number of columns, it will be called what here, somebody? It will be called a square matrix. Like now, these one, ladies and gentlemen, 2, 8, and then we have 3, 9. If this is your matrix A, somebody has given you matrix A like this, and they want you to get the inverse of this, then it is very, very easy for you to inverse. So, and how are we going to inverse? It's very easy for us to inverse. How are we going to inverse these? Basically, 2 steps. So solution, 2 steps. Step number 1, ascertain the determinant. So the first step is to give us the determinant. And how do we get the determinant? Getting the determinant is very easy. You take the PPD minus the PSD. Anytime they want you to get the determinant, you shall be taking the product of the primary diagonal, product of the primary diagonal minus product of the secondary diagonal. So please write this in full. This is determinant equals product of primary diagonal, PPD. PPD is product of primary diagonal. And then PSD is product of secondary diagonal. Product of secondary what here? Diagonal. Now, I know you guys know rectangles. I know you know squares. So when you have a square like this, if this is A, B, C, D, you know the diagonals move like this. Diagonals move like this. And then you must have been told by your teachers that the primary diagonal will be that diagonal that starts from the first square, from the first corner. From the first corner. So that diagonal that runs, like now here, the first diagonal is this one that starts from the first element. This diagonal is what we call the primary diagonal. Primary diagonal. So ladies and gentlemen, please listen here and listen to me very carefully. I would want to get PPD. I would want to get product. Product means I multiply. So in this case here, PPD will be 2 times 9. Because I'm multiplying. 2 times 9, ladies and gentlemen, is what here? It is 18. It is 18. And then I'll go to the secondary diagonal. The lagging is also called lagging diagonal. If this is primary, then the other one will be secondary. So it will be 3 times 8. So 3 times 8 gives me what figure? Somebody there, it gives me 24. So then, ladies and gentlemen, once I have that, I shall be able to determine, to ascertain the determinant, which is PPD. Please don't confuse. We must start with the primary diagonal, which is PPD. PPD is 18 minus product of secondary diagonal, which is 24. So what is 18 minus 24, somebody? 18 minus 24, you guys are correct. 18 minus 24 gives me minus what here? Minus 6. It gives me minus 6 like that. That is step number 1. You ascertain the determinant. After ascertaining the determinant, now you go straight away and do the last thing. You define the universe. Define, so universe definition. So step number 2 is the one of the universe definition. So step number 2, the last step here is universe definition. Universe definition. And how do we define our universe, my friends? To get my universe, I will come and take 1 over the determinant times 1 over the determinant times 1 over the determinant times 1 over the determinant times. Inside here, I will do 2 things. Number 1, I will swap. You swap primary elements. You swap them. You swap their positions. You swap the primary elements. And then you change signs. You change signs of SE. You change signs of SE. So you swap primary elements, and then you change signs of secondary elements. So you've said here that the universe will be 1 over the determinant into you swap the primary elements. PE stands for primary elements. And then you change signs of secondary elements. So remember, this is my main matrix, ladies and gentlemen. So therefore, my universe will be equal to 1 over the determinant. Fortunately, we had obtained our determinant. So it's 1 over the determinant, which is minus 6, into our abracadabra now. Inside brackets here, we've said that the first thing that you need to do is to swap. Swap means exchange. So these are your primary elements. You exchange them. So here we have the 2. They are 9. So you're going to reverse. Now you're going to have a 9 and 2 like that. 9 and 2 like that. And then now, thanks, Irene. Ladies and gentlemen, then from there, what do I need to do? I will come right away here and listen here. I'll come right away here and leave the secondary elements intact. Secondary elements that don't change their positions, no. Secondary elements, I leave them intactly in terms of positions, but I have to change their signs. I have to change. Thank you so much. I can see in this case here, Bill. I can see Alice. So in this case, you can see both of them were positives. So in this universe, they'll become what here negatives like that. So -8 and then -3 like that. Please, please never try to distribute this inside. This automatically marks the end of this. I'll be telling you later on when I come to my tomorrow's class, this is a scalar. I'll be telling you why we prefer leaving this thing like that. So what you need to do again for the number of years I've taught. I also taught high school some time back there. If you want an A, you must be very organized. It's not even about your handwriting, but you must be organized. So once in this case, you finish a question, you writing an answer to a question, you must draw the attention of the examiner to your answers. So you'll come and do what here, somebody double underline, for example. Right? And then you leave some space when you go to the next question and ensure that there are gaps in between. Don't have your work in this case here being congested. So is it correct to write -1/6? Yes, it's correct. Thanks for asking the question here, Alice. You see here, if you write -1/6, still is the same. It is the same. It is the same. Thank you very much. Now, I will want to use this concept tomorrow, but for today, before I disappear, I would want us to look at this question that came in 2022, Mathematics Paper 1, Kcse Mathematics Paper 1, 2022, question number 1, 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 question number 1. So question number 1, ladies and gentlemen, what do we have here? So this is Kcse, Kcse Paper 1, Kcse Paper 1, Kcse Paper 1, 2022, remember, it's 2022. Question number 1. Question number 1. So question number 1, ladies and gentlemen, they give us a nice question here. They gave us a nice question here. So we have here 1/4/5 plus 2/3 of 2, 1/4 minus 3/10 all over 5/6 plus 22/39 times 1, 2/11. 2/11. So remember, they told us we solve this without using a calculator. You solve this without using a calculator. I know you guys are bright. What they wanted to test us here basically is body mass. So solution. So solution, ladies and gentlemen, solution here, solution. So they want us, ladies and gentlemen, there to use body mass, right? I know some schools you could be using here instead of O, you're using BD mass, right? BD mass for indices, but body mass is the most common one. So remember, this stands for brackets. We have of, division, multiplication, addition, subtraction. All right, body mass. Now, ladies and gentlemen, please listen here. Of course, we must use this criteria when you want to tackle this. The first body mass concept is for you to know that you shall evaluate the numerator separately. You can't mix this. You evaluate the numerator separately, and then you come and also do the working for what you know. So first of all, we are going to start our arithmetics from this, the numerator. And of course, here we don't have any brackets, so off becomes the first thing. So first of all, I have to handle this off. So we handle the off. So what I'll do, I'll come and start here with the off. So we have 2/3. Off means multiply, of course. So, but you see this 2¼ we must change it to an improper fraction. How do we change it to an improper fraction? Changing this to an improper fraction, it's 2 times that diagonal. So I'll say 2 times 4 plus 1. Whatever I will get, I will come and divide with the existing denominator there. I know you guys don't have a problem with changing a fraction to an improper fraction, right? Like Irene now tells me that this is supposed to be what here, somebody? It's supposed to be 9/4. 9/4. 9/4. Are we together up to here, really? Are we together up to here? 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 Right? Because 2 1/4, I can't write it 2 1/4 like that. I'll need to know how to convert these into an improper fraction. Right? These guys are not smiling at me. They're not talking to me at all. So I don't know what to do, because for me to move forward, I would want to know whether you're together. People must smile. Yes. Yes, like 3/2. I can see what they're great. Great. Thank you so much. So I can decide in this case to put it as 3/2, but if I'm the one doing this, no worries. I'll simply come and I know 2 goes here twice. I know 3 goes into 9. How many times here, somebody? 3 goes into 9. How many times here, somebody? 3 times, like that. So then the final answer here, I think this student had already done it. The final answer is supposed to be 3/what? 3/2. Thank you so much. 3/2. Thank you so much. And then, ladies and gentlemen, after I do that, now I already have an answer for this. This one I know it's 3/2. So I know that the next thing, of course, is to come and do what here, because you see now I don't have multiplication here. The next thing here will be for us to come and add. So what are we adding? So we are taking this plus this. Great. So we are taking this plus that. So we have, ladies and gentlemen, here, we have this one, which is 1/4/5, plus now that one, which is 3/2. So I'm adding. Remember, first of all, I have to change this to an improper fraction. So can somebody in this case here, Cynthia, already have seen what you've said? Thank you. So could you kindly come and change this to an improper fraction? Tell me what do we have. Change this to an improper fraction. Tell me what do we have. So we have, ladies and gentlemen, there, 1 times 5, changing this. This will be 1 times 5 plus 4, all over the existing denominator, which is 4. So somebody is telling me that this is 5 plus 4. This is 9. 9 over who? 9/5. Thank you so much. So it will be, look at this. So this will be 9/5 plus 3/who? 3/2. Thank you so much. So of course, this means that I have to put an LCM. So here I don't really have to sweat it out. Getting an LCM here is very simple, right? Getting an LCM here is very simple. So LCM of 5 and 2, 5 and 2 is how much? LCM of 5 and 2 is how much? LCM of 5 and 2 is how much? LCM, it's 10, isn't it? It's 10 years. It's 10 years. 10. And then now we ask ourselves a simple question. 5 gets into this twice. So then 2 times 9, 2 times 9, this gives me 18. Plus 2 gets into this how many times? 2 gets into this 5 times, right? So 5 times 3. 5 times 3 gives me how much here? Somebody gives me 15. So then at the end of the day, I'll end up getting 33 over what here? Somebody? 33/10. 33/10. Great, great. So meaning, ladies and gentlemen, that these now, when I combine these two like this, now I have 33/who? 33/10. So now I'll come and do the last thing, which is now subtraction. Thank you very much, Moses. Thank you very much, Treaser. Great, great. Now I'll come and do now the last thing. So the last thing, I hope you guys are following. The last thing that I need to come and do here is not, you know, the whole of this now we know is 33/10. So it will be 33/10 minus 3/10. These are the negative now. Now I'm subtracting. I'm subtracting. So in this case here, could you kindly give me the LCM of 10 and 10? LCM of 10 and 10 is what here? Somebody LCM of 10 and 10? LCM of 10 and 10. LCM of 10 and 10. It's 10. Thank you very much. It is 10. It is 10. So then could you, so 10 of course goes here once. So 1 times 33. This gives me 33. Minus 10 again goes here once times 3. This gives me 3. Which at the end of the day then will give me 30. Because 33 minus 3 is 30. So 30 divided by 10, which will end up giving me, I saw somebody saying 3. Yes. I saw somebody getting 3. Yes. I saw somebody getting 3. I saw somebody getting 3. Thank you so much. So in terms of the numerator, complete. And remember, the good thing with you guys is that your examiner normally marks the method. At times, your answer could be wrong. So you see, even in your marking, the examiner saying M3 or M2 A0. M2 means method for the methodology, the steps you used. You got 2 marks, but the answer is wrong. And that is why I always tell my students here to do what here to ensure that they are really writing their steps very well, ensure that you are very well organized like that. So now we can go, ladies and gentlemen, to the denominator. So this denominator in terms of body mass, Which operator should I start with for the denominator in terms of body mass? Which operator should I start with? Which operator should I start with? I can see Alice is smiling, which is so good, right? So good. So in this case, is there somebody who is saying I can't start with the class when there is a multiplication? There is a multiplication. So I'll go the way I would write this, ladies and gentlemen. This thing wants a student who is able really to talk, right? So in this case here, I will even come and write now the denominator computations. And then of course I can even write for the examiner first of all multiplication, because the more I write also, the better. So multiplication is 22 over 39 times, but now this needs some adjustment. I need to rework out this. So I need to change this to an improper fraction. So improper fraction will be 1 times 11 plus the numerator. And then everything will be divided by the current. So this one here will be 11 plus 2. So 11 plus 2, that is 13. 13 over what here, somebody? 13 over 11. Thank you, Cynthia. This will be 13 over 11 like that. So it is 22 over 39 times 13 over 11 times 13 over 11 times 13 over 11. Unfortunately, I can see something very nice that 11 can go into this twice. I can see 13 going into this how many times? Thrice. So it means that these, at the end of the day, will give me 2 over what here, somebody? At the end of the day, this will give me 2 out of 3. At the end of the day, this will give me 2 out of 3. 2 out of 3. 2 out of 3. This will give me 2 out of 3. 2 out of 3. Thank you. But please don't get so much excited. Always look back, right? A good soldier must always look back. Otherwise, he'll be shot from behind. Look back. Where am I? I'm so sure, ladies and gentlemen, as I wrote here, I was talking about multiplication. So, and I've taken care of this. This is what I've gotten as 2 over 3. So then I need to come and now do the addition. I need to come and do the addition. So the addition now, I know it is 5 over 6. Now plus this, which is 2 over 3. 2 over 3, right? This may need some LCM. So what is the LCM of 3 and 6? 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 It is 6, isn't it? No, Irene, sorry there, you are a bit wrong. Look at this. You are told, if, for example, you have like, say, 3 and 7, and you want to get LCM, you see here, the easiest way here, you can't take 7 divided by 3. If you try to take 7 divided by 3, you'll get, in this case here, decimals. So the easiest way, when you get such kind of a situation, you're supposed to multiply. So the LCM here will be 21. But what if, for example, somebody gives you like 3 and 9? You can't multiply them to get LCM. Why? Because if I take 9 divided by 3, I'll get a whole number. So remember LCM, if you want, the easiest way is to look at the numbers, how they are structured. Really, like now 3 and 7. So 3 and 7, if I take 7 divided by 3, I'll get decimals. So it means that the only way of getting LCM is to come and multiply 3 and 7. This will give me 21. But you see, when I take 9 over 3, I'm getting a whole number. So whenever I get a whole number like that, it means that the bigger figure automatically is the LCM. The bigger figure is the LCM. And this is applicable between these two, because you take 6 divided by 3. You take 6 divided by 3, you'll end up getting a quotient that is a whole number 2. So whenever I get the 2, which in this case are able to fit well within each other, then straight away I know that the bigger one is the LCM. So the LCM there is 6, right? So in this case here, 6 goes here once times 5. So this gives me 5 plus 3, goes here twice. 2 times 2 gives me 4. So we have here 5 plus 4. 5 plus 4 gives me 9. 9 over 6. If you wish, you don't have to do it. But if you wish, you can say 3 goes here thrice, 3 goes here twice. So this will give me 3 over what here? Somebody, this will give me 3 over 2. It is not lost on me. I'll still go back. Remember, there was some numerator that I finished working with. Then there's this denominator value that I've now gotten here. So we go back. I don't know whether there is anybody who is able to remind ourselves what the numerator figure was. There is a numerator figure that we got up there. Is anybody who is able to remind ourselves what the numerator figure? I remember it was something like what here, somebody, what the numerator value. Teresa has remembered. So the numerator value was 3. So come and divide this by the quotient that we have here, this structure that we have here, which is 3 over 2 like that. which is 3 over 2 like that. Then, ladies and gentlemen, here, what am I supposed to do? I'm supposed to come and take, of course, and say this is the same as 3 divided by 3 over 2, which is the same as 3 times 2 over 3, because I have to reciprocate this. So this and this will end, and then the final answer will be what here? Will be 2. The final answer will be 2. If you guys were in a college, and that is why I would want you to work very hard, you come to university or a college, you would have drawn an emoji for this person, college level, because now you are so sure you are right. But high school, don't try this. High school, don't try writing this, right? There still you're not, right. So I'm so happy because at the end of the day, ladies and gentlemen, I have what there? I have my 2 like that. So now we have come to the end of today's session, right? It is my hope that you guys have enjoyed the session, right? You're being taught by a doctor, right? And my work basically is to simplify this thing and to help you time your exams. So I'm going to give a homework through WhatsApp. I hope all of you are in our paid app group WhatsApp, right? So I give you a homework of two questions. You try and then you send back your answers to WhatsApp. I'll be able to mark them later. Before 8 p.m., I should be able to mark them. Now, that takes me back to